My name is Anthony Ingraffia. I am the Dwight C. Baum Professor of Engineering Emeritus at Cornell University and a Senior Fellow at Physicians, Scientists, and Engineers for Healthy Energy. I'm going to show two versions of the same graph. The first version is taken directly from a paper that was published 6 years ago. It shows the history of global warming, starting with the beginning of the 20th century. The squiggly black line is raw data, actual data taken of global climate change, temperature increase, global warming. At the time this paper was published in 2012, the data went up to about 2009. At that point, the authors of this paper made speculative simulations. Each of these solid curves is the result of one scenario where they imagined what might happen in the future should mankind decide to do certain things with regards to fossil fuels. So these were predictions, and as such they were subject to error. But note that every one of the predictions predicted that we would be in the 1.5 degree centigrade temperature rise, that which the Paris Climate Agreement says we should attempt to avoid, and each one takes us into the 2 degree temperature rise still in this century. I have added here a series of red dots. Each of those red dots corresponds to a global temperature rise as recorded by NASA. You'll note a couple of things from this chart. First, all the simulations done back in 2010, 2011, 2012 were wrong, regardless of the scenario. Worse, they were wrong in the worst possible way. Every one of these scenarios underpredicted actual global warming, whereas the worst case scenario brought us to 1.5 degrees centigrade in 2040. We're almost there today. We will certainly be there in the next 2 or 3 years. If you extrapolate from these red dots, meaning that we don't do anything significant about fossil fuels, and especially shale gas, we will be in 2 degrees centigrade territory within the next 10 to 15 years.
An average global temperature increase of 2 degrees Celsius, 3.6 degrees Fahrenheit, will bring catastrophic changes. Even compared against a change of 1.5 degrees Celsius, 2.7 degrees Fahrenheit, heat waves would last around a third longer. Rainstorms would be about a third more intense. The increase in sea level would be higher, and the percentage of tropical coral reefs at risk of severe degradation would be much greater.